Hello friends, today I'm excited to share with you some new features regarding statistical distributions in the Desmos Calculator. They've already had the normal and the binomial distribution for many years now, but they've made some great improvements now that I hope you'll find useful to your classroom, and I hope your students find them useful as well. So we're just going to walk through a few examples today. So first we're going to look at the normal distribution. And I have an example here for us to follow along with. The average Halloween trick-or-treater collects 3.2 pounds of candy. Standard deviation 0.6 pounds. Assume the distribution is approximately normal. So this might be a somewhat tenuous context, but we'll use it for the sake of being able to use the calculator. So if you follow along with me here, nothing has changed with normal distribution. We type in normal dist, and I use parentheses. And I have a mean of 3.2 and a standard deviation of 0.6. And I can see the curve, and I can zoom fit the curve. If I click the zoom fit button here on the left, and I can see the distribution of candy here. But what's new is under cumulative probability, some of the commands have changed. And notice right away already, it defaults to showing me the proportion of candy within one standard deviation. So already I have a default here, and we notice that's 0.683. So let's just walk through a few scenarios, probability questions we might want to do with this new tool. So for example, what's the probability a child collects more than 4 pounds of candy? Well, let's explore these region buttons here. We have inner, we have outer as well. So we go outer, we go left, and we can go right. So more than 4 pounds of candy is definitely a right distribution here. And we want the probability x is greater than 4, and I can see that that is 0.0091 very clearly. In addition to that, you might notice some other things here in the top. 0.0091 has a great little gray drop-down box, cumulative probability, with a little checkbox where I can take this number now and import it into my next area here to do mathematics with. So for example, if I knew that 300 students were going out trick-or-treating, I can now multiply this number by 300 and have an estimate for the number of students or children who get this much candy. So we have new buttons here for inner, outer, left, and right, and I hope you agree that they're somewhat snazzy and intuitive to use here. Let's do a couple more examples here. What's the probability a child collects between 2.5 and 3.5 pounds of candy? Sounds like a nice haul to me, a lot of Twix hopefully in there. So we will do an inter probability here. So this inner, we want to be between 2.5 and 3.5. And I can find that that is 0.57. So very easy to find the probabilities I like here. Okay, so they've changed things a little bit here, inner, outer, left, and right. Let's do one more example here. How much candy must a child collect to be at the 90th percentile? So here's a new addition that's somewhat exciting here. Before, if we wanted to go backwards and think about the inverse normal distribution, right now we just kind of need to guess and check our way through it. But now we have the ability to do that under this compute feature. We have area, but we also have bounds. Let's see what bounds does. So bounds, notice, I have the ability to input something here on the right-hand side, an area, and it will give me the bounds. So to be at the 90th percentile, well, that's a left-tailed area, and I would like 0.90. And I can see that in order for a student to be in the 90th percentile, they have to get almost 4 pounds of candy, 3.969. And again, with the gray drop-down box here at the arrow, I can then put that into my expression list and do things with it mathematically. So they've changed some buttons here, and hopefully for the better, and I hope you agree that they're a little bit more intuitive and perhaps have some added features of things that we might want to do with distributions. Let's take a look at the binomial distribution. Binomial distribution, here's an example. 20% of all automobiles undergoing an emissions inspection at a certain inspection station fail the inspection. A random sample of 15 cars is taken. What is the probability exactly 3 cars fail the inspection? So let's look at the binomial distribution. So I'm going to get rid of what I did here before, and let's go to binomial dist, again parentheses. And if you didn't know, trials and success probability, they tell us what we need here. We are looking at 15 cars, and the success probability is 20%. And I want to zoom in on that probability, and I have this nice picture of the distribution here. Let's take a look at cumulative probability. Oh, so notice it defaults to this area somewhat in the middle here. So keep in mind the mean of this distribution would be 3. So we're right around the mean of the distribution here. So it defaults to between 2 and 4. What's the probability exactly 3 cars fail the inspection? Well, there's a couple ways to do this one. I could use inner, outer, left, and right, but I'll remind you that in a binomial distribution, all you need to do is just click on the top of the associated bar, and I can see the probability exactly 3 fail inspection is 0.25013. I could have done that as an inner, I suppose. We could do 3, 2, 3, and it gives me that single bar as well. It's also very nice to click these dots and see what's happening with them. Okay, fantastic. What other sort of problem do we have here? Was the probability more than 3 cars fail inspection? Okay, well, this could be our right tail distribution, more than 3. X is greater than or equal to 3, so more than 3. So that implies 4 or more. So notice I have a greater than or equals to argument here. So I actually want 4 or more, and that gives me 0.352. So very exciting. Now, if you haven't done this before with binomial distributions, I encourage you to try to play with sliders on it. Let's say that this distribution, that the probability changes here from 0.2 to something that I'll just call P. So let's call it P, and P is between 0 and 1. Notice the default's to 0 and 1. And we have a good old time here investigating the binomial distribution for different P's. And overall, when does it seem like a binomial distribution appears to approach a normal distribution? And you can do the same thing for n here and come up with different n values. So have your kids play and notice that my values here are getting lower as the probability gets lower. So really great to deal with the binomial distribution. So I hope that that's some nice new features here and a little bit more cleaned up from what they were before. All right, this next one is brand new. I hope you're as excited as I am for the chi-square distribution. So here comes our chi-square distribution. I don't have an example problem for this, but I just want to show you chi-squared is now here. Chi, C-H-I-S-Q, chi-squa, and we're going to call that dist. So it's a little bit nomenclature that you have to know here. Chi-squared distribution. Enter the degrees of freedom. Let's go with 6 degrees of freedom, and I will zoom fit that. So I now have the chi-square distribution of 6 degrees of freedom. And we can see the point up here. The mean of this distribution appears to be around 4. And now I can do cumulative probabilities like I can before. Now, usually with the chi-squared, we're not interested in cumulative probabilities that are inner or outer, but there might be a purpose where you would need that. Usually we're looking at left-tailed areas, or actually right-tailed areas, now I think about it. We want to know the probability that we get a chi-squared statistic as extreme as 8, perhaps, and we can see how unusual that might be. And the place we might also want to look here is with bounds. Let's say that I was doing a chi-square test with, let's change the degrees of freedom, with 10 degrees of freedom, and I want to know the critical value for a 5% region. So I can find out when this comes out as 0.05, and I could see that I would need a chi-squared statistic as extreme as 18.31 to do that. So some great improvements made to the normal and the binomial, and a fantastic addition with the chi-squared. I hope you enjoy them and find use for them within your classroom.